All right, system of linear equations is a set of two or more linear equations containing two or more variables. So for our purposes, we're just going to use x and y. And the idea is that you have this system. So these two linear equations, they are a system, and they can be used together to find a solution that has to satisfy both of these equations. If it only satisfies one of them, it doesn't work. It has to satisfy both. So it's kind of like you're using friends to help each other find the answer. And so solutions are written as an ordered pair. So you have your x and you have your y. So with this particular example here, my x is 4, my y is 1. If I go back and I plug it in, x is 4, so 4 plus 2 is 6. And if x is 4, 4 minus my y of 1 is 3, and it works. So 4, 1 is the solution to this system. All right, so let's say we have this question. It says, is -1, 2 a solution to the system below? And I'm going to figure that out by substituting in these values. So I'm going to plug in -1 for x, and I'm going to plug 2 in for y. So I started it over here just so you could see it. 2 times -1 is -2. 5 times 2 is 10, so -2 plus 10 is 8. So it works. So far, this works. It works with this one. So now let's try it with the other one. So we have 3x minus 2y equals 5. So we're going to use -1 for x. So it's going to be 3 times -1 minus 2 times my y of 2. And we want to see if that is equal to 5. 3 times -1 is -3. 2 times 2 is 4, so it's going to be -4. And we want to see if that's equal to 5. Well, -3 minus 4 is -7, and -7 is not equal to 5. So it does not work for this. So since it doesn't work for both of them, this is not a solution to this system. So this is kind of just like a guess and check method of seeing whether or not something is a solution. Another thing that you can do is you can actually graph the equations. So I can graph these two linear equations, and where they intersect each other, if they intersect each other, then that is a solution to the system. Again, this is considered the system. So I'm going to start, I'm going to graph this first one, y equals x minus 3. The -3, and I'm sorry, my tablet broke, so it's hard for me to write here. I'm having to write with my finger on a mouse. My y-intercept is -3, so I'm going to put a point down here at -3. And then my slope here is 1. There's not a number in front of the x, so that means 1. Remember, slope is rise over run, and so since these are both positive, that means I go up 1 over 1. So I'm going to put a point right here. Now I'm going to connect the dots, and we'll just use this one right here. And so I connect the dots, and that's my first equation. That's the y equals x minus 3. So now let's do the next one. Y equals -x minus 1. This is my y-intercept at -1. So I'm going to put a point here at -1. Y-intercept is just where it crosses the y-axis. It doesn't mean that's what all y's are equal to. It's just the y-intercept. It's where it crosses the y-axis. Now my slope here, I see -x, which means it's -1. So the slope is -1 over 1. That's my rise is -1 and my run is 1. So if I'm coming back over here, I go down 1 over 1. So it's going to be right here at this point. So I'm going to connect these dots. And so because these two points intersect right here, that means this is the solution to this system. And so we're going to look at the point starting here. This is the point 1, -2. So this point here, 1, -2 is the solution to this system. So when I can even go back and I can check it because I can plug in these values. Let me erase all of this. If I go back, and I plug in these values, I'm going to plug 1 in for x and -2 in for y. It should work. 1 minus 3 is -2, so it works on that one. -1 minus 1 is -2, so you can see it works for both of them. So I can So a way I can find the solution to a system is by graphing them, and the point that they intersect, that's the solution. All right, let me show you one more. We have x plus y equals 0. Remember, this has to be written in the form, this has to be written in slope-intercept form, y equals mx plus b. So I'm going to rewrite it by subtracting x from both sides. This is y equals negative x. And so when I'm graphing it, I'm going to start by finding my y-intercept. And since there's not really anything here, say really, there isn't anything there. My y-intercept is 0. We don't put the plus 0 because it simplifies without it. So, but I'm going to go ahead and I'm going to put a point. Let's put green. Let's put a point right there. Okay. And the slope is negative 1. So that means it's negative 1 over 1. So I go down 1 over 1. So that's that point. And then I'm going to connect the dots. And actually, I'm going to have to move this. I know that's not right. Make sure it goes in a little bit better. All right, so there's that one. Now I'm going to graph the other one. This is y equals negative 1/2 x plus 1. My y-intercept is at positive 1, so I'm going to put a point right here at positive 1. And my slope is negative 1 over 2. Negative 1 over 2. I know that's really big, but so that means my rise is negative 1, and then my run is positive 2. So I'm going to put the point there. And again, we're going to connect them. And this, hold on. Let me move it so that it matches up better. All right. And that still is not good. This is what happens when you don't have a ruler. You're having to rely. Okay, so we can see right here at this point is where these two lines cross. So that means the solution, negative 2, comma 2, or the point, I'm sorry, negative 2, comma 2 is the solution to this system. So if I plug in negative 2 for x, and 2 for y, it works. So negative 2 plus 2 is 0. That one works. Negative 1/2 of negative 2 is positive 1. Plus 1 is 2. So it works for both of them. So the solution is negative 2, comma 2.